Hello, I'm Jim Pamplin, and it is my honor to introduce our speaker, Dr. John Baumgardner. Dr. Baumgardner has a PhD in geophysics from UCLA. He spent most of his career at Los Alamos National Laboratory. He is currently at Liberty University, a professor emeritus in Virginia. And you can find more information about Dr. Baumgardner at globalflood.org and at logosresearchassociates.org. Please welcome Dr. John Baumgardner.
Thank you, Jim. It's a distinct honor to be with everyone tonight, or if it's morning, depending on where in the world you are. And my topic is a linguistic argument for God's existence. And I would like to begin by setting a little of the context. In most intellectual circles today, the prevailing outlook is that of philosophical materialism, and this has existed. This outlook has prevailed for several centuries in much of the world, and the foundational premise of that outlook is that matter and energy is all there is. So I'd like to address that question, that issue that serves as the foundational premise of philosophical materialism. Again, this outlook has been a pillar of Western intellectual life ever since the so-called Enlightenment of the 1700s. And just to try to be more precise about what we're talking about, I've got a couple of dictionary definitions of materialism. One from dictionary.com defines it as the philosophical theory that regards matter and its motions as constituting the universe and all phenomena, including those of mind, as due to material agencies. The Collins English Dictionary defines materialism as the monist doctrine that matter is the only reality and that the mind, the emotions, are merely functions of it. Now, let's take a look at a couple of people who were unabashed materialists over the last century or so. I begin with Carl Sagan. In his Cosmos series, he stated, "I'm a collection of water, calcium, and organic matter called Carl Sagan. You are a collection of almost identical molecules with a different collective label. But is that all that we are? Is there nothing in here but molecules?" Some people find this idea demeaning to human dignity. For myself, I find it elevating that our universe permits evolution of molecular machines as intricate and subtle as we are. So here is someone who was a convinced materialist, and that was his outlook. A little before Carl Sagan, we have Bertrand Russell, who was an eminent mathematician, philosopher. And in an essay he wrote near the turn of the 20th century, he says that man is a product of causes which had no prevision of the end they were achieving, that his origin, his growth, his hopes and fears, his loves and his beliefs are but the outcome of accidental collocation of atoms, that no fire, no heroism, no intensity of thought and feeling can preserve an individual life beyond the grave, that all the labors of the ages, all the devotion, all the inspiration, all the noonday brightness of human genius are destined to extinction in the vast death of the solar system, and that the whole temple of man's achievement must inevitably be buried beneath the debris of a universe in ruins. All these things, if not quite beyond dispute, are yet so nearly certain that no philosophy which rejects them can hope to stand. Only within the scaffolding of these truths, only on the firm foundation of unyielding despair, can the soul's habitation henceforth be safely built. So that expressed Russell's outlook, and the essay was A Free Man's Worship, written in 1902. So this is a sampling of what this materialist outlook reflects. All right, so what are some of the logical implications of that philosophical view? Well, first, the human being is nothing more than a temporary collection of atoms. The notion that a human being has a soul and spirit is nonsense. The claim that angels and other spirit beings exist is superstition. In other words, there's nothing supernatural, hence there's no God within what is real. Again, that's trying to help people grasp just what this framework claims. Philosophical materialism established a strong foothold in European universities in the early 19th century, grew to dominate most of them by the end of that century, as well as the top universities in the United States. Since the mid-20th century, its dogma has been strictly enforced through most North American universities, and over the past 50 years, it has also come to dominate K-12 public education by university-trained teachers and actively enforced by the teachers' unions. So this is an important aspect of the culture of the world in which we live today, and so that's the context that I want to speak for the next few minutes. A deeply alarming aspect of this anti-God, anti-Christian philosophy is that it has advanced largely unchallenged. So I say, how can that be? With as many Christians as there are in the United States, does no one have an effective response to this framework? But on the other hand, how does one counter the truth claim that there is no non-material reality in an effective way? That has stumped a lot of people. How do they counter that truth claim? Well, let me suggest that one way is by producing an indisputable example of non-material reality, ideally one with which we're all familiar. And if you can do that, then basically you have falsified that foundational premise, that foundational assumption of philosophical materialism. So is there a clear example of non-material reality with which we're all familiar? I argue that the answer is yes, and that example is language. Language is so integral to our own mental processes that most of us rarely, if ever, pause to analyze just what is occurring when we think, write, speak, or process what we read or hear others say. It is therefore crucial to begin our discussion with providing a simple, clear, and precise definition of this term language. So what is language? Well, in trying to reduce it to the simplest definition I can come up with, I offer this as a definition. It's simply encoded meaning. All language is encoded meaning. So how is meaning encoded in a language? Well, first of all, small snippets of meaning are assigned to a set of tokens or symbols, which we usually refer to as words, and the resulting set of words from all these small snippets of meaning forms what is usually referred to as the vocabulary. And then, in addition, a set of rules, usually referred to as the grammar, is specified by which the elements from the vocabulary may be joined together to create more complex meaning structures. So here's an example of the assignment of meaning to tokens or symbols. In this case, the tokens are sounds that human beings can make. And in all these in this example, the same meaning, snippet of meaning, is assigned to all these different tokens. So here we have, let me just give these tokens: dog, Hund, quien, Sabaka, Kane, Perro, Gao. So there's a key aspect of a language is the assignment of meaning. And here we have, I'm showing how this works. Note that apart from the assignment of meaning, the tokens or symbols in themselves have no meaning. The token or the sound is arbitrary, and one can come up with an entirely new language where you have a new set of tokens. You assign the meanings that you want to a given token, and you create a vocabulary. So here's an example of joining vocabulary elements together, in other words, words together, to form a more complex meaning structure. And we have this sentence in English: the guide dog led the blind girl through the city traffic. So it's an example of how, using the grammar, one is able to build arbitrarily complex meaning structures from a vocabulary and a grammar. So what are some examples of language, different kinds of language? Well, of course, we have human language, but we also in our day have computer language, which humans have developed, created. We have mathematics, which qualifies, as I'll show later, qualifies according to the definition of language that I've given. And in addition, we have genetic language, all examples of language that satisfy this basic definition. So I want to examine where language fits in terms of reality. I'm arguing that language is non-material in its nature. It's non-material reality. And that is because meaning is abstract and non-material. And if that's so, because that's so, so is language. Language is merely encoded meaning. This is why the meaning of a linguistic message that a linguistic message conveys does not depend on its material carrier. A message, if reliably encoded and transmitted, is the same whether it is via paper and ink, on a magnetic disc, a plastic CD, or chiseled on a rock. So meaning is independent of matter. Again, a linguistic message, when reliably transmitted, is identical whether it's carried by acoustic waves through the air, relayed electronically, faxed, email, encrypted, sent through the mail on a DVD, or carried via smoke signals. The message has an identity and a reality independent of its material carrier. So to reiterate here, language conveys meaning, language encodes meaning, language expresses meaning. The essence of language is the meaning it conveys. And because meaning is a non-material entity, so is language. Now, I realize many people struggle when they first exposed to this idea that there's something that we participate in almost, well, all our waking moments, and probably much of the time when we're asleep, that is non-material, and that it's so much a part of who we are. But I know that's not easy to get used to. But I'm claiming that meaning, and let's just say the meaning of the words that we use, that meaning is something that is not built out of the elementary particles of physics. It's something else. It's non-material. Meaning is non-material. Now, Albert Einstein grasped this fact. He recognized that there exists a gulf logically unbridgeable between the realms of concepts and propositions, that is language, and the realm of what we see, hear, taste, and touch, that is what is physical. And in a magazine interview he did in 1944, he said, "We have the habit of combining certain concepts and conceptual relations so definitely with certain sense experiences that we do not become conscious of the gulf, logically unbridgeable, which separates the world of sensory experiences from the world of concepts and propositions." Now, linguists have picked up on that quote from Einstein, and they now could refer to the gulf which Einstein described between the physical world and the realm of concepts as the Einstein gulf. So he realized that there is an unbridgeable gulf between objects in the material world and this realm of concepts and meaning, propositions, and so on. Now, I use this slide as an attempt to illustrate what we mean by the Einstein gulf. On the left, I have a photograph of our dog Tiffany when she was a puppy, and on the right side, the word dog, but more than that, the meaning of the word dog. A bodily thing such as a dog shown on the left exists on the side opposite the Einstein gulf from the meaning of the token used to refer to the dog. The two entities are in a separate category of reality, separate categories of reality. The meaning associated with the token is not a material dog, and the dog is not the material token, not the material meaning of the token. So, so that's a quick description of what we mean by language in terms of human language. But we also have computer language. Language, as we've defined it, includes not only ordinary human languages, but computer or machine languages as well. And where we do this very thing, we assign meaning to certain, depending on the language, whether it is, for example, C or C++ or Python, certain words we can define. We can define words in that language and assign meanings to them. And then there are rules for manipulating those words. And so we can create complex software doing that. Software, by the meaning it carries, enables the complex electronic circuitry in computer chips to perform astonishing feats. Without the software, the hardware would accomplish nothing useful. However, enabled by software in the circuitry of our smartphones, for example, it allows us to place calls to a good fraction of the Earth's inhabitants, provide detailed navigation instructions for driving in a strange city. It can recognize our speech and can search the web to provide verbal answers to our spoken questions. Note that downloading a new app does not alter the mass of one's phone by even a single atom. So we could completely erase all the software from our smartphone, and the smartphone's mass would not change by even an atom. Language is truly a non-material phenomenon. And then we have industrial robots. The machine language expressed in the software of industrial robots enables these robots to fashion and assemble most of the parts required in our automobiles and many of the other machines and appliances we use today. The power of this non-material reality to shape the material reality around us is almost beyond what we can imagine. Here, robots assemble Chrysler and Dodge minivans at a plant in Ontario, Canada. And here a vehicle is welded by a robot in a GM assembly plant in Michigan. And all this is directed by linguistic instructions, by language. Software enables the infrastructure of modern society at a myriad of levels, to most of which we are mostly oblivious. So there's all kinds of software that enables our traffic signals to be coordinated and enables all the telecommunications that happen. Just staggering how much modern society relies upon machine language and verbal language, human language for that matter. So an inescapable fact is that non-material reality in the form of software instructions today prescribes and controls the physical reality around us in ways almost beyond our ability to grasp. Some, however, might still be asking, can language somehow have a material cause? But when one surveys the diverse fields of physics, for example, classical mechanics, thermodynamics, electromagnetism, optics, quantum mechanics, atomic physics, molecular physics, nuclear physics, relativistic mechanics, high-energy particle physics, cosmology, one finds no hint that matter can possibly assign meaning or manipulate it at any level. None whatsoever. So the laws of physics offer no indication anywhere that matter has a language generation capacity. Elementary particles, atoms, and molecules simply have no ability to assign meaning or recognize meaning-bearing symbols. The inescapable conclusion is that language demands a non-material cause. Not only is it non-material, but it demands a non-material cause for its existence. What about emergence? Some 30 years ago, especially in that time frame, materialists were speculating that language or even intelligence or consciousness might emerge when matter is organized in extremely complex ways, such as in electronic networks with trillions of interconnected transistors. The quest to demonstrate such behavior, however, has proved utterly fruitless. In the absence of software, there's no hint whatsoever of linguistic response in these complex computer networks. And so here's a little photograph of a Intel Core i7 processor on a silicon wafer, several of these processors. Each one has 1.4 billion transistors in this case. And so thousands of these processors can be linked together, or even millions today. And there's no hint whatever of any language or intelligence or any kind of linguistic capability emerging from that complex interconnection of circuits. So what about random processes? Can they possibly generate meaning-bearing linguistic sequences? Well, consider the sequence of 800 characters in the next slide that was generated randomly with the same letter frequencies found in typical English text, including that of the blank. I wrote a little program some years ago which did that, generated random sequences of English letters and included a blank in the set of symbols. And as you look at this sequence, you don't see anything that resembles meaning-bearing symbols. Certainly not in English, but I would say it not in any human language. And there's a simple reason why this process produces only gibberish. It's because the defining aspect of language is missing, namely the assignment of meaning. So that all you get when you have symbols generated randomly is gibberish. Uh, and actually, if you randomly change symbols in a meaning-bearing sequence, you transform it into gibberish because you're destroying the meaning that was originally assigned. So we've shown that machine language is language in the fullest sense as we've defined it. What about mathematics? Does mathematics qualify as language? Yes, mathematics involves the assignment of meaning to sets of symbols and specification of a set of rules or axioms for manipulating the symbols. And there's a major implication of the fact that mathematics is language. The fact that mathematics is language implies that the laws of physics are a linguistic description of the structure of the material world itself. In other words, what this the fact that mathematics is language implies that there is implies there is a linguistic underpinning of the material universe, because we have discovered these laws of physics that are linguistic in character. So this is an example of the laws of physics, what are known as the Maxwell's equations, discovered something like 170 years ago. And these simple equations basically describe all electromagnetic phenomena. This describes light, the propagation of light, but all other kinds of electrical phenomena. The material realm thus has linguistic underpinnings. This implies that the material realm cannot be explained or understood solely in terms of material entities. Its linguistic constraints are an essential ingredient. These linguistic attributes of the material realm are beyond the reach of materialist explanation. So most materialists haven't appreciated that hard reality, that the material world cannot be understood purely in terms of the material entities themselves. There's something more fundamental, these laws of physics, which are linguistic in character. Similarly, life specifications are non-material and therefore also beyond the reach of material explanation. Indeed, prior to the mid-20th century, no one even speculated or imagined that the genetic specifications would turn out to be linguistic in nature and therefore be non-material. But as after the structure of DNA was discovered and people started looking at the details of DNA, it was found that these genetic instructions in DNA are indisputably linguistic. The DNA language clearly makes use of an alphabet, a vocabulary, and a grammar. The DNA alphabet consists of 4 letters, A, T, C, and G, the 4 nucleotides in DNA. The vocabulary for describing proteins consists of a 64 3-letter word dictionary, which we'll look at in a moment. And however, only a few of the grammatical rules for what's encoded in DNA have yet been discovered. Certainly how DNA encodes proteins has been discovered. That grammar is well known, but overall, there's still a lot of undiscovered aspects of the DNA message. So this is the DNA dictionary for coding proteins. It consists of 64 3-letter words. Each of these 3-letter words is referred to as a codon, and an amino acid means are assigned to each of the 64 three-letter words, except for this last one, which are punctuation codons. So all the rest of them, however, refer to an amino acid. And most amino acids have more than one word that refers to it. So this enables a much more compact coding than otherwise would be possible. It allows overlapping meanings to be overlapping messages, if you will, to be encoded using the same letters in the DNA. In other words, you have one message for one side of the DNA, and the complementary strand of the DNA also, in most cases, carries a real and important message. And the fact that these letters, more than one word, can refer to the same amino acid makes that possible. The discovery of the details of how DNA carries and transmits heritable genetic traits has resulted in a major crisis for neo-Darwinian theory, by the way. That crisis is simply that it is not possible to account for the non-material coded linguistic specifications within the limitations of a strictly materialist philosophical framework. So what implication does the non-materiality of language have for materialist philosophy itself? Well, it should be clear, should be obvious that it is fatal to that philosophical framework, because it falsifies its foundational truth claim that there are no non-material realities. But as we consider language, it's a huge counterexample, and it's futile to argue that language is not real. It makes materialist philosophy logically indefensible. Language represents an unambiguous counterexample to the assertion that matter plus energy in all its forms is the full extent of what is real. As I mentioned earlier, only one substantive counterexample is sufficient to falsify that truth claim of materialist philosophy. And so what this means is that materialism, which has been taught as dogma in most of the world's universities for the past century or more, is founded on a claim that is demonstrably false. And in my view, it's time for Christians to turn the tables and demand that materialism no longer be taught as exclusive dogma in our public educational institutions. It's so easy to demonstrate that philosophical outlook is not intellectually defensible. It's possible to go on the offensive and say we just cannot tolerate such error being taught in our schools. So let's go back to the biological realm and take a glimpse of what life is like at the molecular level, and reflect a bit more on the role that language plays in this at this level in living systems. Living systems are filled with tiny machines like this biped robot, composed of a single protein known as kinesin, shown walking along a microtubule. Now the circle at the top of this little character is a vesicle, a container that this robot is carrying along. And so this next slide gives a little clearer picture of the same robot carrying this transport vesicle from one part of the cell to another. The robot walks along what sort of represents the internal skeleton of the cell, these microtubules that go crisscross the cell like cables, and allows these little robots to carry these containers from one part of the cell to the other. And this whole system, it corresponds to a UPS delivery system at a micro scale, basically throughout the cell. The microtubule network is shown here. This is from some monkey liver cells, and these microtubules are stained red, while the cell nuclei are stained blue, and you can see how dense these microtubules are within each cell. Now, each step that this kinesin robot takes utilizes one molecule of what is known as ATP, adenosine triphosphate, to provide the energy that robot needs to take a step. This ATP molecule is actually the primary energy carrying molecule, which powers most cellular processes in all living organisms. This chemical formula is given here. Its structure is shown on the right. And the way the molecule works is that when one of these when the last phosphate unit detaches, energy is released, and the amount of energy is right at the amount that is needed for most cellular processes to take place. So this is a very important aspect of what happens in cell metabolism. But for this all to work, there's a need to reconstitute the ATP, to put that phosphate which has been detached back on, and that requires energy. And so there's a special machine known as ATP synthase that performs this task. It reconstitutes the chemical energy currency, the ATP, that powers all these machines. And this ATP synthase machine spins at up to about 10,000 RPM. It is driven electrically by a flow of protons and exists in every form of life on Earth. So this is an attempt to visualize what this little machine looks like. The upper part rotates. It's called the rotor, and it's driven by hydrogen atoms, protons, and there's a gradient in the proton concentration from the outside of the membrane to the inside, and it produces a flow of protons that turns this rotary machine. And the bottom part of the machine is stationary, and it has catalytic activity, and that's where the ADP, adenosine diphosphate, is combined with a phosphate unit to get the energy carrying ATP back again. So many of our cells contain hundreds of thousands of these tiny rotary machines, that many in a single cell. The amount of ATP produced per day in our bodies roughly equals our body weight. So if you weigh, say, 150 pounds, that means that every day the cells of your body reconstitute about 150 pounds worth of ATP. So that's a major aspect of what takes place at the cellular level in our cells. And this little ATP synthase machine plays a crucial role in how our bodies work, how our cells work at the molecular level. This is a cutaway view of what is called a mitochondrion. These are little potato-shaped organelles in our cells. There's a membrane inside this mitochondrion, and these little ATP synthase machines are embedded in this membrane. And so these mitochondria are sort of the energy, the centers of energy production in our cells. and there can be up to 1,000 of these mitochondria in a given cell, and up to 1,000 ATP synthase machines in a single mitochondria. Here's another schematic of that little ATP synthase machine. Each color signifies a different type of protein, and each ball in that lower part represents an individual atom. So there are about 90,000 atoms in all in this machine. So an incredible amount of complexity here. A large number of different proteins have to come together in just the right way to assemble this machine. And as I said, this machine exists in every form of life on Earth, from bacteria to humans, and includes plants and just every form of life. And this is a little animation showing the rotary part of the machine and these little things flying in and out. You have ADP plus phosphate flowing in, and these pinkish entities are the ATP coming out. Again, every form of life, bacteria, plants, animals, and people have large numbers of these machines. Moreover, all this complex machinery, such as ATP synthase, is manufactured within the cell. So how does that work? Well, let's look at how this manufacturing takes place. There's another special molecular machine known as a ribosome that has the ability to assemble proteins, all proteins. The coded in specifications for each protein that gets manufactured are carried by a string of messenger RNA that has been copied from DNA in the cell nucleus. So this green strip here is a strip of messenger RNA. It gets threaded through the machine, and then it specifies how these what are called transfer RNAs, tRNAs, each one has attached to an amino acid, how those are brought together in just the right sequence to produce a specific protein. Again, the complexity of what goes on at the molecular level is just boggles the mind. So this summarizes what I was just saying, that the specifications, the linguistic specifications, are encoded in the cell's DNA for making the protein. These little dashed arrows toward the bottom represents the process of copying a little bit of what's in the DNA to RNA, messenger RNA, and then processing through a ribosome to produce these various proteins, which then have to come together to form the molecular machine. There are a few molecular machines that consist of just one protein, but most of them involve more than one protein. Okay, in other words, language specifies the detail of every living organism down to the level of the individual atom. Just astonishing. So we have life engineered down to the level of individual atoms, just the ultimate of nanotechnology. And language enables that to happen. But where does language come from? How does language arise? We discussed earlier how it appears that matter itself cannot generate language. So how does language arise? Again, if the laws of physics show that matter in itself has no language generation capacity, whatever, and that this means that language must have a non-material cause, just what might that cause be? Well, we can take cues from our own human experience that our own linguistic capacities seem to be associated with thought and mental activity. In other words, when we speak, when we write, basically we Generally, there's something going on in our minds uh, that results in that production of language. In short, it appears that certainly in the case of humans, language comes from the mind. So is that universally the case, that all language is the product of mind? If so, the logical consequences are profound. If the linguistic content of all the genomes on Earth, as well as the linguistic content of all the laws of physics, are the product of mind, the number of viable candidates for such a mind would seem to be quite restricted. In fact, I can identify only one candidate, namely the God of Scripture, that has the mental capacity to generate all the genomes of the organisms on Earth, as well as the laws of physics. So, in conclusion, it's straightforward to show that language is a non-material phenomenon. That should be beyond debate now. As such, language falsifies the claim that non-material realities do not exist, and thereby falsifies materialist philosophy. And finally, our next, because matter displays no capacity to generate coded meaning, language must have a non-material source. The only candidate source, I would say, for language is mind. I would challenge anybody to come up with an alternative. And the only candidate mind that can account for the language structures in the world around us is the God of the Bible. Pretty straightforward chain of logic here. And these ideas are in a paper that myself and Jeremy Lyon published in 2015 in the Journal of the Theological Society. It can be downloaded for free online from the Answers in Genesis website. The title of that paper is the same as the title of this talk, A Linguistic Argument for God's Existence. So thank you very much for your attention. I hope this has stimulated your thinking. And if we're in an online situation, I'm open to take questions. So thank you very much.
Thank you, John.